Lesson 2.2 is on transforming data. We looked at our heights of the class and we converted them all to centimeters. And the question was, what happens to the summary statistics if I change all of our data values to centimeters instead of inches? What we noticed was they all got multiplied by 2.54, the conversion factor. So we also want to look at what would happen if we add or subtract to all the data. How does that change the summary statistics? Because we need to be able to identify what the new mean and standard deviation and median IQR are going to be without having to change all the data every time. Now we should have noticed that our percentile didn't change. Whether it's in centimeters or inches, our height was still had 5 people shorter than us or 20 people shorter than us. So our percentile didn't change. When we looked at z-score, that also didn't change. So transforming data is useful when analyzing distributions of quantitative variables. When we need to convert units, for example, our height thing, we converted from inches to centimeters. Maybe we need to convert from Fahrenheit to Celsius. Maybe we want to convert from kilograms to pounds. Maybe the measuring device was calibrated wrong, so we want to add a constant to each value to get an accurate measurement. We want to know what kinds of effects these transformations, adding or subtracting, multiplying or dividing, have on the shape, the center, and the variability. This is our essential question. Okay, that's what we're looking at today. What we should have noticed from our height thing was the resulting impact on our statistics was everything got multiplied by 2.54. So our mean of 66.45 got multiplied by 2.54. Same with our standard deviation, the minimum, the Q1, the median, the Q3, the maximum, and the IQR. So now what we want to look at is what happens when we add and subtract a constant. What do you think might happen to our height in inches? Let's say we decide we want to know how much taller or shorter you are from 5 feet. So we're going to subtract 60 from all of our heights. That makes my height of 67 inches a value of 7. What do you think is going to happen to our statistics? Stop to think about that for a sec. Okay, so in our calculators, we're going to subtract 60 from all the data. So in here, I go up to highlight the list name. Okay, this doesn't work if I'm inside the list. I need to highlight list 6, and I'm going to ask it to take list 4, which in my case is the heights, yours might be list 1, and subtract 60. So I'm going to do second, and then I hit 4 because that's list 4. Down here, see it says list 4 minus 60. So now these are all the heights and how much over or under 60 inches, which is 5 feet, they are. So we have some negative values, 11 inches taller and negative 1 inch taller, so 4 foot 11, and so on. Okay, so how does this affect our summary statistics? Well, it kind of makes sense if our minimum is 57 and I subtracted 60 from that value, then my minimum is now going to be negative 3. My Q1, which was 63, right? That was somebody's height. We subtracted 60 from all of them, so that's now going to be 60. And the median is going to be, not 60. It's going to be 3, sorry. The median, subtract 60, I'm going to get 8. Q3, I'm going to get 10. Max, we're going to get 14. Let's look at the summary statistics in the calculator. So I go to Stat Calc, one var stats. The list that I had subtracted the 60 from is in list 6, and I'm going to hit calculate. And there's my mean of 6.45, which is 66.45 minus 60. And notice the standard deviation. The standard deviation is still 4.4. So my standard deviation did not change. My IQR is now 10 minus 3, still 7. My range is 14 minus negative 3, 14 minus a negative 3, still 17. So I moved everything down 60. It changed all of my measures of position and location, minimum, Q1 median, Q3 max, mean, but it did not change my measures of spread. So what we need to take away from this is that when we add or subtract to our data, the new summary statistics measures of center, the mean and the median, measures of location, the min, Q1, Q3, and the max, all changed by the constant minus 60. But the measures of spread, standard deviation, SX, IQR, and range stayed the same. Because I didn't make anything more spread out. When I'm multiplying all the numbers, my min and max gets farther apart, and so my spread changes. No, you're going to write down this. Adding the same positive number, A, or subtracting A from each observation, adds A or subtracts A from measures of center and other measures of location, like Q1, Q3, and the min and max. It does not change measures of variability. It does not change the range. It does not change the standard deviation. And it does not change the IQR. And it also does not change the shape of the distribution. So we have 30 students in a statistics class. The test was worth 50 points, and here's a dot plot and the summary statistics for that test. Let's say the teacher, Mr. Tabor, was being really nice. Maybe he didn't like one of the questions, so he just added 5 points to everybody's score. How is that going to change the distribution of the scores? How is that going to change the statistics? How is adding 5 points to everybody's score going to change the shape of the dot plot? If I just add 5, so this point's going to become, this point here moves to here, right? It's just moving everything down, right? It doesn't change that shape. Basically, this becomes 15, 20, 25, 30, 35, 40, 45, 50, and 55. It didn't change anything about the shape of the distribution. It just changed the numbers that it's over, right? We're still going to have the same shape. How is it going to change the mean? It's going to go up by 5, right? So the new mean is going to be Hold on, let me put it on. I'm going to put it underneath here. The new mean is going to be 40.8. Does that change the standard deviation? The standard deviation change? Is it going to become more spread out if I just change the numbers on the axis? No. So what's the standard deviation? 8.17. It's going to be the same. What's the new minimum? 17. What's the new Q1? Wait, we're adding 5. 37. The median is 42. Q3 is 46. The max becomes 53. Notice the IQR, 46 minus 37 is still 9, right? And my range, 53 minus 17 is still 36. Okay, so the key is to remembering when we're adding, we don't add to the standard deviation, IQR, and range. Don't add to those three statistics.
To SD, IQR, and range?
Yes. Soon after the metric system was introduced in Australia, a group of students were asked to guess the width of their classroom to the nearest meter. Shown below is a dot plot of the data along with some numerical summaries. The actual width of the room was 13 meters, and we can examine the distribution of students' errors by defining a new variable. As follows, the error equals the guess minus 13. Note a negative value for the error indicates that the student's guess for the width of the room was too small, and a positive would mean it was too big. So what shape would this new distribution have? We're taking all these values and subtracting 13. We're going to look at the error, and that's the guess minus 13. So these are all these guesses and how big the room is. Does the shape change if I'm making it error instead of guess? Does the shape change if I'm subtracting from the data? No. Okay, so the shape is still going to be, how would we describe that shape? Skewed to the right. And possibly bimodal. It is kind of close together, those two peaks. What will the new mean and median be? By higher or lower? What are we doing to all of the data? We're subtracting 13, right? So if the mean is 16.02, what's the new mean going to be? 3.02. If the median is 15, what's the new median going to be? Minus 13? 2, right? And then what about standard deviation? Does that change? So the standard deviation stays the same, 7.14, and the IQR stays at 6. Okay, so these are the type of questions you're going to be asked in the homework. What's the new mean and standard deviation? Now, we saw when we converted to centimeters that everything changed when we multiplied by the data. So if we were to take the statistics about the test that we just looked at and multiplied everything by 2 because I wanted to make it out of 100 points, which we do all the time as teachers, right? We take a test, it's 20 points, we convert it to a percent, essentially multiplying by 5, right? So what happens to the distribution? Well, this data was skewed left, right? The original data. When I multiply that by 2, the data is still skewed left. But you can see that it's clearly more spread out, right? If I were to just move everything up 5, it doesn't become more spread out. But if I multiply by 2, it's definitely more spread out. So when I'm multiplying by a constant Everything gets multiplied, even the standard deviation, the IQR, and the range. You can see that the IQR, if you look at 46 minus 17 and 92 minus 34, the new Q3 and Q1, it is twice, right, what it was before. And same with the range. So what you need to write down: transforming data, multiplying or dividing by a constant. If I multiply each data value or divide each data value by the same positive number b, it multiplies measures of center and location. That's the mean, the median, the min, the Q1, the Q3, and the max. It multiplies the measures of variability, but it does not change the shape of the distribution. Okay, that you're going to write down.